Good morning everybody. It is the first class of HS second year. Due to the pandemic situation, it is not possible to conduct the classes in the normal classroom situation. So, our college has decided to conduct the classes in the online system. So, this is the first class of HS second year in the Department of Statistics, and I shall discuss about the finite difference in this class. Let x be an independent variable and f of x be the function of x. As we know, any variable may be considered as the independent variable and the function of the particular independent variable is the dependent variable. So, if we consider x be any independent variable, so the function of x, that is f of x, may be considered as the dependent variable. In finite difference, the independent variable takes a very vital role, plays an important role. The independent variable may have the values either in equal width or in unequal width of interval. So, if we consider x takes the values a plus h, a plus twice h, a plus n h, so it is considered that the random variable x takes the values of equal width. In this case, the difference between two consecutive values are always same, that is a plus h minus a is equal to a plus twice h minus a plus h. But in case of unequal width, the difference between two consecutive values may not be equal, that is x 1 minus x 0 may not be equal to x 2 minus x 1. So, in finite difference there are some important definitions. So, at the very outset we shall discuss about the arguments, entries and some different operating systems. That is, first, that is argument. The values of the independent variable are called arguments. If x takes the values, that is independent variable takes the values a plus h, a plus twice h, a plus n h, then these values are the, that is arguments are taken from the independent variable x when the intervals are in equal width. But if we consider the values x 0, x 1, x 2, x n, then it is clear that the values are considered, that is the arguments are considered from the unequal width of intervals of the independent variable. Then entries. The values of the dependent variable are called entries. If f of x be the function of x and it takes the values f of a plus h, f of a plus twice h, f of a plus n h, then these are the values of the dependent variable, that is these are the entries for the independent variables when the independent variable takes the values of with equal width of intervals. But if we consider the values f of x 0, f of x 1, f of x 2, f of x n, then it implies that the functions of the independent variables has taken for the values of the independent variable when when the values of the independent variables, that is arguments, are not taken from the equal width of intervals, that is they are taken from the unequal width of intervals. Then forward difference operator. The constant difference between two consecutive values of a dependent variable is called the forward difference operator. Subject to the condition f of x plus h minus f of x exists, that is in forward difference operator the difference will be taken from the succeeding value to the preceding value of the arguments, of the entries. And it is very important to say here that the forward difference operator only takes place when the interval of widths of the independent variable are in equal width. Forward difference operator may also be defined as delta. So, delta can be defined as delta f of x is equal to f of x plus h minus f of x. Then backward difference operator. The constant difference between two consecutive values of the dependent variable is called the backward difference operator. Here the condition is that the preceding value, the difference will be taken from the preceding value to the succeeding value, that is f of x minus f of x plus h. So, backward difference operator is defined as nabla, and it is defined as nabla f of x is equal to f of x minus f of x plus h. Here it is very clear that the backward interpolation backward difference operator and forward difference operator are just of reverse order. That is, in case of backward forward interpolation forward difference operator, we do the difference, we take the difference from f of x plus h minus f of x, and in case of backward difference operator, we take the difference of f of x minus f of x plus h. Then shift operator. If f of x be any variable and takes the values f of a, f of a plus h, f of a plus twice h, and so on, so then the shift operator can be defined as e f of x is equal to f of x plus h. In shift operator, the shift operator can also be defined as capital E, and it is defined as e f of x is equal to f of x plus h. It is very clear that for all the three types of difference operators, the equal width of interval of the independent variable will be taken. So, here we shall discuss about now the relation between delta and e operators. So, by definition, delta f of x is equal to f of x plus h minus f of x, and e f of x is equal to f of x plus h. So, consider the first relation like this. So, what happens here? Size is 30. So, in place of f of x plus h, what we can do is equal to e f of x minus f of x. So, take f of x as a common factor. So, we can write capital E minus 1 then f of x. So, here we have taken f of x as the common factor. Mind it, while taking f of x as a common factor, the operator e minus 1 should be placed before f of x, because the operators will be operated on the function. So, function should be written later than the operators. Now, in both the cases, that is delta f of x and d minus 1 f of x is the common factor. So, we can omit f of x. So, we can write here delta is equal to e minus 1. So, this is the relation between delta and e operator, and we can find this like this manner. Okay. Then the extension of e operator, that is by definition e f of x is equal to f of x plus h. It is very well known to us. Now, we want to establish the relation in the extended form. That is how. So, let us have this. So, here place this relation E square. E square, change the font size and the font style also, that is 30. Then E square f of x, sorry, square f of x, change the font style and font size 30, then that is time domain, okay, f of x, no? That is equal to E f of x. So, is equal to E f of x means f of, sorry, E f of x means f of x plus h, oh sorry, x plus h. Now, what to do? In place of x, we have to write x plus h. So, E f of x plus h, that is equal to f of x plus h bracket close is equal to f of x plus twice h close. Now, look here it is written in this manner, E square f of x. Then what happens? F of x plus twice h, that is the index of E and the coefficient of h are equal. Now, let us have the same discussion. So, suppose it is 3. It is 3, it is 3, copy, then paste. So, it is 2. Suppose in place of E square, we can write twice h. So, 2, then again twice h, that is E square f of x. E square f of x means f of x plus twice h, then E f of x plus twice h. Now, in case of f of x, we can write f of x plus h for this E. For this E, it is E f of x plus h, and this twice h will remain same. Then it is 3. So, now it is very clear that the coefficient of h and the index of E are same. So, now have the another one, suppose now it is suppose n. So, in this case we can write it is n minus 1. So, we can state it like this, n minus 1, that is n minus 1 h. So, it will be it will be n minus 1 h. So, it will be n, So, here the coefficient of h and the index of e are same. So, we can say it e to the power n f of x equal to f of x plus n h. In this manner, we can extend the e function. Okay. So, like this manner we can establish the function of e. So, I think for today it is quite enough. So, we shall meet once again in the next class. So, for this for today this is enough, I think so. So, have a nice day, and the final slide is thank you. So, we can write thank you slide like this manner. Yes, thank you.